Hello student, I am Dr. Anamika Goyal from ABES Engineering College, Ghaziabad. Today I am going to discuss the next topic of Unit 5th of the subject Design and Analysis of Algorithm, that is Theory of NP-Completeness. In this lectures, first I am going to discuss about the introduction, that is what is the meaning of theory of NP-completeness. After that we'll discuss some classifications of an algorithm on the basis of their execution time and on the basis of their applying method. After that we'll discuss some key concept of NP-completeness, that is also called NP class. And last we'll discuss the concept of theory of NP-completeness with the help of suitable example. So let's start our topic. First of all, what is the meaning of theory of NP-completeness? The theory of NP-completeness is nothing but it is a fundamental concept in computational complexity theory, which explore the difficulties of solving algorithmic problem. Basically, NP-completeness is a concept on computational complexity theory where we explore and finding how we can finding the difficulty where we have to solving the problem. In easiest term, we can say the meaning of theory of NP-completeness is all about finding that which problem are easier and which problem are hard to solve. So, if I'm talking about the easiest problem, then those kind of problem which we can solve or which computer solve in quick manner, we can say in linear time. So these kind of problem is are called easier problem. If I'm talking about the hard problem, so the problem whose execution time in exponential mean it will time taking procedure. So these kind of problem are hard problem. So this is basically the concept of NP completeness. To find out the two different categories of the problem, first one is the easier problems and second one is the harder problem. So, before understanding the concept of NP completeness, we also try to find out the meaning of algorithm. So, algorithm is nothing but it is a sequence of well-defined instructions to solve a specific problem and to perform a computation. Algorithm basically classify into two different categories. First one on the basis of their execution time and second one on the basis of their applying methods. If I'm talking about the classification of algorithm on the basis of their execution time, so algorithm can be classified into two different categories. First one is the polynomial time algorithm and second one is the non-polynomial time algorithm. First of all, what is polynomial time algorithm? So it is basically a easier problem. Easier problem means the problem which computers solve quickly. Quickly mean the problem which computers solve in linear time. So for example, like linear search. The complexity of linear search is order of n. If n number of item in a list, so the time complexity of linear search is order of n. Similarly, binary search. Binary search also take order of log n time to find a particular key into a available list of item. We also say merge sort. It will take order of n log n time. And insertion sort, it also take order of n square time. So generally it is a problem which we can solve in easier or quickly manner in linear time. These kind of problems comes in the categories of polynomial time problem. Second one is non-polynomial time problem. That is the second categories of an algorithm, that is called harder problem. Harder problem on the basis of their complexity. Those kind of problem, which will take exponential time to solve, but it can be verified in a polynomial time. So these kinds of problems comes in the categories of non-polynomial time problem. Just like that Sudoku problem. Sudoku problems comes in the categories of non-polynomial time algorithm. We can also say like 0-1 knapsack problem. 0-1 knapsack problem. So the time complexity of 0-1 knapsack problem is 2 raised to the power n. And another problem like traveling salesman problem, that is also solved in order of 2 raised to the power n times. So the problem whose solutions find in exponential time. So these kind of problems comes in the categories of non-polynomial time problem. This is the first classifications of an algorithm. Second classifications of an algorithm is based on the applying methods. So on the basis of their applying method, we can classify algorithm into two different categories. First one is the deterministic algorithm and second one is the non-deterministic algorithm. If I am talking about the deterministic algorithm, so the algorithm which we generally use like linear search, binary search, merge sort, insertion sort. Even we can say till now in the subject design analysis of algorithm, जो भी हमने problems अभी तक discuss किए, these all problems comes in the categories of deterministic algorithm. In deterministic algorithm, we know that how each and every step can work. Like if I'm talking about the linear search. So in linear search, what happened? We know the sequence of instruction. We can say we know the definite path to solve a problem. So deterministic algorithm are those kind of problem where we have some input and we also define some process, and with the help of this process we can find out the output. So we have some definite part of the problem which we have some definite path. These kind of problems comes in the categories of deterministic algorithm like linear search, binary search, merge sort, insertions, or all those problems comes in the categories of deterministic algorithm. If I am talking about the non-deterministic algorithm, so non-deterministic algorithm are those problems which cannot have definite path. For a single input we have one or more out, right? So so we can say in non-deterministic algorithm we have choice. We also have on the basis of their choice function we also have some success and failure. So the algorithm basically use three functions: choice function, success function, and failure function. These kind of algorithm are comes in the categories of non-deterministic algorithm. I hope you understand the concept of deterministic algorithm and non-deterministic algorithm. To understand the concept of non-deterministic algorithm, let us take an example. These are the example of searching a particular key into a available list of items using the deterministic algorithm. Let us assume we know the searching is a hard problem. It is a new problem. It is a hard problem. We don't have any idea how we can find a available item into in particular key into a list of available items. We don't have any idea. We don't know anything about the linear search and binary search, and also we just take is a fresh problem. Search a particular key into a list of available items. So how we can write a solution to solve a particular problem, right? Initially, when we try to find out the solutions of a given problem, so firstly, let us think about the non-deterministic kind of solution. Means we have lots of option to find out the solutions of a given problem. For a single input, we have multiple output. We have choice. This concept is called no, this concept is called non-deterministic approach. इनिशियली जब भी कोई रिसर्चर भी किसी पर्टिकुलर प्रॉब्लम का सोल्यूशन फाइंड आउट करने की कोशिश करता है, के लिए ट्राई करता है, तो सबसे पहले वो भी एक प्रॉब्लम का नॉन डिटर्मिनिस्टिक कोड ही राइट डाउन करता है. तो अगर हम सर्चिंग की प्रॉब्लम का नॉन डिटर्मिनिस्टिक कोड देखें, तो अकॉर्डिंग टू दैट कोड, suppose we are just giving a list of item A 5 10 2 4. This is what? This is an array, and 0 A of 0 5, A of 1 10, A of 2 2, A of 3 4. And what is the value of key? Suppose we want to find a key value 4. Is it available on this list of array or not? So I have to write a non-deterministic algorithm for that particular problem. So first we write I is equal to choice. Choice means number of options, number of solutions. It's a random approach. I is equal to choice. Suppose here we choose key value 10. So I is equals to 10 here. Choice function will select random manner 10. So here I is equals to 10. So if A of I is equals to key, you can compare A of I, it means I is equals to 1, that is the index. So if A of I, A of 1 is equals to 10, A of 1, the value is 10. 10 is equals to 4? No. So we just print 0 and failure. Right? Another form, suppose I want to, suppose in another choice, I randomly choose I is equals to 3. So in that case, you compare A of 3 is equals to 4. Yeah, A of 3 is equals to 4. So in that case, you just print the value of I, that is the location of I3, and print success. So in that case, the searching cost, or we can say the time complexity of this non-deterministic algorithm is order of 1, because in constant time we find a list of items. So our solutions is depend on that particular statement, that is I is equal to choice. Basically, this statement represent non-deterministic approach. This statement represent non-deterministic approach, because in this statement we have lots of choice. We have four options. We can choose I is equals to 0. We can also choose I is equals to 1, I is equals to 2, I is equals to 3. And on the basis of their choice value, it depends that our output is success or our output is failure. So these kind of problems are called non-deterministic approach. After that, researcher will work on that particular approach to find out or to convert this selection procedure in a phase manner. Just if I'm talking about the linear, so researcher will choose I is equals to A of 0. Will start at 0th index and process till end of the array. If I'm talking about the binary search, so researcher will use the concept to find out the value of I is mid. And what is the mid value? Mid is equals to low plus high divided by 2. So on the so researcher will replace this non-deterministic concept in linear search I is equal to 0th index to till end, and for binary search it will replace this concept mid is equals to low plus high divided by 2. I hope you understand the concept of non-deterministic algorithm. Now we'll discuss some key concept of NP completeness. So if I'm talking about concept of NP completeness, here we come four classes of NP completeness. First one is NP class problem. Second one is P class problem. So what is NP class problem or what is P class problem? So first NP. Here NP is not polynomial. Here NP stand for non-deterministic polynomial class. The meaning of non-deterministic polynomial class is that a problem, basically the non-deterministic means a problem which cannot, a problem which cannot be solved in polynomial time, but it can be verified in polynomial time. So these kind of algorithm or these kind of solution is comes in the category of NP class problem. Suppose let us take an example of Sudoku problem. So what is the concept of Sudoku problems? In Sudoku problem, if I am talking about the Sudoku problem, so in Sudoku problem, we have 4 by 4 block. Right? We have 4 by 4 blocks. Suppose we have 4 by 4 block. And we have some random number in different position, like here 1, here 4, here 2, here 6, here 8, right? Like that. We have 4 by 4 block, and will fill some random number, random position like 1, 2, 4, 6, and I have to fill this block with the number 1, 2, 9. But the condition is here that in the same row and same column we can't repeat the number. Suppose in the first column if 1 is here, so we cannot write 1 in this column, in this column, and this column. Or we cannot write one in this rows, in this and this. So this is the basically concept of Sudoku. So to solve this problem is not possible in linear time. It will take exponential time to fill this puzzle. But we can verify this puzzle in polynomial time, because for the verification we just check row numbers and column number, the same entry will be available or not. Again, then for next row same column, then for next row next column. So its verification is possible in polynomial time but cannot be solved in polynomial time. So these kind of problems comes in the categories of NP class problem. I hope you understand. Second categories of NP class concept is P class problem. So P stands for polynomial. So P class problem are those problems which can be solved or produce an output within a polynomial time. Means basically P class problem use the deterministic algorithm for solving or finding a solutions of a given problem. Means here we have one output for a given input, and we have some definite part to solve that particular problem. So these kind of problem comes in the categories of P class problem, like linear search, binary search, merge, sort, insertion, sort. These all are P class problem. So to understand this concept, which will explain you this concept P or NP class with the help of diagram. Suppose this whole circle represent NP. NP means non-deterministic polynomial class. Non-deterministic polynomial class are those class which use what? Which use non-deterministic algorithm. Here, what is the meaning of non-deterministic? What is the meaning of non-deterministic? Means we have choice. We have multiple output for a single input. We have lots of solution and we just optimized our solution. So here we have for NP class problem, we have non-deterministic algorithm, but the execution time of these kind of problem is polynomial, right? That's why it is called non-deterministic polynomial problem. This is NP class problem, right? This is NP class problem. Now what is P class problem? P class problem, it is a subset of NP class problem. This is what? P class. P class, it is a subset of NP class. Why? Because P class based on the concept of deterministic algorithm. Deterministic algorithm are those algorithms which have some definite part to solve a problem. One output for a one input. So we have one approach or one set of instructions to solve these kind of problem, and the time complexity of deterministic algorithm is also polynomial. Right? So in P class, we use deterministic algorithm and the time complexity is in polynomial form. If I am talking about NP class, so NP class basically used a non-deterministic approach to solve or to find a solution of a given problem, but verify these problem in polynomial time. So the large set of problem is a non-deterministic problem, NP class problem. If researcher will able to write the NP problem into a P problem, means if researcher is able to write the deterministic approach of a particular NP class problem, then these problem comes in the categories of NP class problem. These problems comes in the categories of P class problem. So this is the concept of NP and P class. I hope you understand both key concept clearly. Now move forward to our next two more concept, NP hard and NP complete. These concept little bit confusing, but If you focus, then you can understand easily. Next two classes are NP hard and NP complete. So to understand this, let us take an example diagram. So here we again draw a diagram. Our previous diagram, large set of problem is NP problem. NP problem, it is a subset of NP problem. Then we take another problem that is called NP hard problem. These all are NP hard. All the non-polynomial kind of algorithm or non-polynomial type of approach process comes in the categories of NP hard problem. NP hard are those problems which basically use non-deterministic approach to find a solutions of a given problem. So generally, researchers first write a solution of a given problem. To find the solution of a given problem, researcher write non-deterministic approach, non-deterministic algorithm. So NP hard, initially all problem are come in the categories of NP hard problem. If researcher will able to write able to find a solutions of this problem in non-deterministic approach, and the time complexity of this non-deterministic approach is non-polynomial, right? Non-polynomial, we can say exponential. So these kind of problems are NP hard problem. So what is NP hard problem? If we can solve the problem in if in NP hard problem, basic NP hard problem, like 0 1 knapsack problem. It is an NP hard problem because and it will take order of 2 raised to the power n exponential time for find a solution. Or we can also say traveling salesperson problem, TSP problem, whose time complexity is again order of 2 raised to the power n. So these kind of problems are the part of NP hard. Our next class is NP-complete class. A problem is in NP-complete if it is in NP and it is NP hard. For example, knapsack problem and traveling salesman problem. These problems also comes in the categories of NP-complete. Here, what is the meaning of NP-complete? These intersected portion is called NP-complete portion. What is NP? This is NP-complete. So what is the meaning of NP-complete? NP hard problem are those problems which uses non-deterministic approach and the exponential time is non-polynomial, right? If researcher will able, if researcher will able to solve these non-deterministic problem in polynomial time, these non-deter like 0 1 knapsack problem use non-deterministic approach, but the time complexity is 2 raised to the power n. If researcher will reduce these time complexity order of 2 raised to the power n to order of n log n in linear time. So these problem comes in the categories of NP complete problem. So the NP complete problem is if it is in NP and it is in NP hard. So these problems are called NP-complete problem. I hope you understand what is the concept of NP-hard and NP-complete. Right? So here we discuss some important concept of NP class problem. So quickly we revise this concept. We'll discuss 4 kinds of problem with you. P class, NP hard and NP complete. Right? So P class problems are those problems whose execute in linear time. linear time, right? P class problem are those problem whose execution time is linear and use deterministic algorithm. Next, we'll discuss NP class. NP stands for non-deterministic polynomial type class. In non-deterministic polynomial time, these kind of problems verify in linear time but use deterministic algorithm. So P class problem are linear search or binary search, etc. If I'm talking about non-polynomial type class, NP class, so this is a Sudoku class, Sudoku problem. Sudoku means we can not solve this problem in polynomial time, but we can verify these problems in polynomial time. So this is comes in the category of NP class. Then we discuss NP hard problem. Initially, all the problem whose execution time is in exponential form, and use non-deterministic algorithm to find a solution. These kind of problems are called NP hard problem, like graph coloring problem, right? After that, we'll discuss NP complete problem. After that, we'll discuss NP complete class. What is NP complete class? NP complete class problems are those problems which use non-deterministic algorithm, but whose execution time is linear. So these kind of problems are comes in the category of NP class problems like 01 knapsack. Right? This is all about these four class. Now let us take a simple example to understand these concepts. Suppose we are just taking an example of searching. We just taking an example of searching problem. Searching problem means we are just giving a list of element and we have to find a particular key that this key value is present in a list or not. Initially, this is a hard problem. Why it is hard problem? Actually, we don't know anything about the concept of search. It is a new concept. We don't know anything about how do we can search, how do we can find an item into a available list. It is a total new concept. So this is a hard problem. If so, now what happened? Now researcher will try to find a solution of that particular problem. So first, researcher will write a non-deterministic algorithm. Non-deterministic algorithm. For what? For to find a solution of that particular problem. If the researcher will able to write a non-deterministic approach to find a solution of that problem, then this searching problem will comes in the categories of NP hard problem. Right? This problems come initially. This is the hard problem when the researcher will able to write a code non-deterministic approach to solve this problem in exponential time. So this problems comes in the categories of NP hard. Right? This searching problems comes in the category of NP hard problem. After NP hard, we have after NP hard, if the researcher will able to convert this non-deterministic algorithm to generate a solution in linear time, right? So these kind of problems comes in the categories of what? So these kind of problem comes in the categories of NP complete problem, right? So initially we have hard problem when researcher is able to find a solution using non-deterministic approach. So this problem comes in the category of NP hard because the time complexity is here exponential. When the researcher will able to convert this non-deterministic approach and to find a solution in linear time, so this problem will convert into NP complete problem. If the researcher will able to find a solutions, right? After that NP complete, we have two choices. Either we have P problem, either we have NP problem. It means if the researcher will able to write deterministic code and solve in linear time. So this is what? This is P problem. And if the researcher will able to write non-deterministic algorithm and solve in linear time. So this is what? This is NP problem. We all know that in today's scenario, we have two algorithm, linear search and binary search, whose execution time is in linear search order of n, in binary search in order of log n. So what is linear time? And we have a deterministic algorithm because we have a one set of instruction. In linear search, we compare our key value one by one to list of available item. When we find key, we just print success message. In binary search, what we have to do in binary search, we just find out the mid value using lower index and higher index divided by 2, and we compare our key value in each time the mid value. So what happens? So in these two deterministic approach, we try to find a particular key value into available list of items. So in that way, this searching hard problem will convert into a P class problem. Okay. So this is the basic approach to NP, theory of NP completeness. I hope you understand the concept of theory of NP completeness. Wait for a minute. So basically, theory of NP completeness, the concept is here. We just find out the problem. We just find out the problem on the basis of their complexity. We have some problem which are easier and some are complex. If the computer solve this problem in linear time, so these kind of problem are easy problem, or we can say is NP problem. If the computer are not able to generate a solution in linear time, computer will generate the solution in exponential time. So these problems are comes in the categories of NP hard problem. These are the references used in our presentations. Thank you.